We're going to go through the worksheet for the IN6 additional practice. Again, this was not in your books, but something we used to get some more practice. So number one, graph shows the number of possible passengers for a given number of roller coaster cars that leave the platform. Use two sets of coordinates to write an equation to describe the relationship. So writing an equation, we have to have 2 points so we can find the slope of the line. Based off of the numbers that they're using, they were using the points 216 and 324. So if you use the points 216 and 324, when you go to find your slope, change in y, you would do 24 minus 16, which is 8. Change in x, you'd do 3 minus 2, which is 1. And then 8 divided by 1 is 8. Slope is 8. And then remember, we had that equation was y equals mx. And m is our slope, so instead of y equals mx, our equation, we're going to write, since our slope was 8, we're going to put y equals 8x as our equation. Again, you might have picked different points, but you would have come up with the slope of 8 no matter which way you did that if you did it correctly. Part B, interpret the equation in words. We could say each roller coaster car holds 8 passengers. Another option on this problem, since it goes through 0, 0, we know it's proportional. So we've got this kind of unit rate point that we've been talking about, the 0.18, which tells me one car has 8 passengers, and that's what it's going to be. It's 8 passengers per car is what it's going to be, since it goes through 0, 0 and it's a straight line. So since it's proportional, we could actually use that point. Again, it's a good idea also to try to work some of these out, kind of like what the book's doing. Because not every line, especially as we move forward, not every line is going to be proportional. So good to have a backup plan always when we're doing these problems. Number 2, graph relates the actual size of a car in feet to a model of the car in inches. Write an equation that describes the relationship. So this one, if you look for some points, some good points here would be 0, 0, and 3, 1. It does go through 1.5, 1/2, but that's not as nice of a point, really. 3, 1 would be a much nicer point for you guys. And then basically using those 2 points like we've talked about, we're just looking for basically what's my change in y, what's my change in x. So from 0, 0, change in y, how far are we going up? Well, we're going up 1. And then change in x is how far we're going over, and we're going over 3. So up 1 over 3, our slope is 1 over 3, or 1/3. And so that means our equation then would be y equals 1/3 x. So y equals 1/3 x is the answer for number 2. Number 3, they want us to graph the equation y equals 2/3 x. So y equals 2/3 x, we know is proportional because it's in that y equals kx form. They're not adding or subtracting anything. So we know it's going to go through 0, 0. And then since the slope is 2/3, from 0, 0, you could go up 2 and over 3. Change in y is 2, change in x is 3, is how we can get to another point there. This time they're actually going by 1, so you can literally go up 2 squares and over 3 squares would take you to the 0.32. And you could continue doing that if you wanted to, up to and over 3 again, okay, in order to come up with your line here. And in this case, the negative numbers don't make sense. That's why we're going to stay in the first quadrant. Do notice the arrow on the right side of that when we graph it, though. So that's one way of doing it. Another way we talked about is you could make a table and just pick some points. If I'm picking points, since I have y equals 2/3 x, 0 I always like. So if you put a 0 in place of x, that'd be 2/3 times 0, which is just 0. And then since I have a fraction, it's going to be easiest to pick the denominator as your next x value. So if you put a 3 in place of x, I've worked out over here, 2/3 times 3 would be 6/3. 6 divided by 3 is 2. That's how I got that 0.32. And then if we put in the next multiple of our denominator is going to be another point that keeps us from having fractions. So if we put a 6 in place of x, 2/3 times 6, that would be 12/3. 12 divided by 3 is 4, so that's how we can get that 0.64. Okay, so like I said, either we can use the slope if you're able to do that, or you can actually just substitute points in. And really, for a long-term solution, substituting in, making a table is going to be a good way of doing these problems as you guys go on, because things are not always going to be proportional, and they're not always going to go through 0, 0. So it's good to have more than one option when you're figuring out the answer to these problems. Number 4, a volunteer replaces broken bricks on a walkway for 5 hours each week. After 3 weeks, he has worked 15 hours on the walkway. What is the constant proportionality for a relationship between the number of weeks and the number of volunteer hours, and what is the slope? So we can just think about, first of all, 0 weeks, they would have worked 0 hours, so you can graph the 0.00 to start out with. And then we know after 3 weeks, they have worked 15 hours. So if you kind of fill in the blank here, in between 12 and 16, that missing number would be 14. And so 15 is going to be halfway between 14 and 16. So that's how we can get to this point, 315. And then just draw a straight line that goes through 0, 0, and 315. So from that, you could say we go up 15 and over 3. So 15 divided by 3 would be 5. So 5 would be our slope. 5 would also be our constant of proportionality. And then part B, use the slope in the point 315 to graph the line. Technically, we've already graphed it if you started at 0, 0 and you went through 315. Another thing we could do using the slope, we could say slope was 5, which is change in y over change in x. So if that's 5, that's like 5 over 1. So what that means is from a point on the graph, change in y is 5. That would be going up 5 and over 1. Now obviously they're not going just by ones here on their blocks, so that actually equates to going up 2.5 blocks and over 2 blocks. But anyway, up 5 and over 1, just look at your numbers. So we were at 15. If we go up 5, takes us to 20. And if we go over 1, our x would be at 4. So 420 would be another point on the graph. And that would be another option, another way that you could graph that equation. Part C asks, why is the line graphed only in the first quadrant? Basically, the reasoning there is that the number of weeks and the volunteer hours can't be negative. Okay, for sure, we can't volunteer negative hours. Okay, technically, maybe you could argue having negative weeks of, like, -2, that was 2 weeks ago or something like that, but for sure, we cannot volunteer negative hours. Number 5, they want us to graph the equation y equals -10x. So we know we have a negative slope, so think about what direction that's going to be going. We do know this is proportional, so we could start at 0, 0 automatically if you want. -10 is our slope, which is like -10 over 1. So one way of doing this, slope is -10, change in y over change in x, so that's -10 is like -10 over 1. So from 0, 0, change in y is -10, we could go down 10, which is actually going down 1 square here, and then over 1, which is really like over 2 squares. Okay, so -10 over 1, and then use that to graph your line. Would be one way of doing it. Another way of doing this would be just to make a table. So 0, 0 we've got. If you put a 1 in for x, that's like -10 times 1, which is -10. Okay, so that's 1 -10, which is what we just talked about on the graph there. And then if you put a 2 in for x, that's -10 times 2, which is -20. So 2 -20 would be another point on the graph. And then again, the nice thing about doing a table like that, if you get 3 points that line up, that's saying something. Okay, 3 points lining up is a pretty good indication that you have graphed this correctly. If you just use the slope and say, I'm going to go down this many and over this many, if one of your points is wrong, you don't have a way of double checking that. Any 2 points will line up with each other. So I highly recommend the table. You get a 3rd point, and then you can double check that those actually are lining up with each other. Number 6, they want us to use the point -26 and have a slope of -3. There's no equation here, so we have to just use the slope basically in order to come up with this. So -26 point would be up here, and then using that slope of -3, -3, that's -3 over 1. So basically from that point -26, we can go down 3, that's a -3, and over 1 gets us to another point on the graph, which is -1, and then that's technically enough for us to graph our line. If you wanted to, you could go down 3 and over 1 again, would take you to another point, which happens to be 0, 0. They don't tell me that this line is proportional, so we can't just make the assumption, oh, it's going to go through -26 and 0, 0. No guarantees about it being proportional. Okay, so don't just assume 0, 0 to be on every graph. Number 7, longest aerial tramway in the United States is at Sandia Peak in New Mexico. Graph shows a relationship between the time of the tram ride and the elevation above the base. They want us to use these points to write an equation that describes the relationship. So looking at the points here that they've given us, we know slope is a change in y over change in x. So change in y, we could actually just subtract those y values. So again, make sure you have the y value, not the x value, when you're subtracting up in the numerator. So 2,546 minus 1,273 is 1,273. Change in x is 10 minus 5. Again, make sure you go in the same order. We started with the y value of that second point, means we have to start with the x value of the second point also when we're subtracting. And then 1,273 divided by 5 is 254.6. So that's our slope. It's not a perfect number by any means, but there's definitely worse numbers we could have gotten. So that means our equation is y equals 254.6x. So y equals 254.6x. And then part B, they want us to interpret that. So interpreting that, we just did feet divided by minutes. So that's feet per minute. So unit rate, basically. We could say the tram rises, since it's positive. The tram rises 254.6 feet per minute. And then part C, explain why the line is valid only for the first quadrant. Basically is that the time and the elevation can't be negative. For sure, elevation can't be negative because it's saying that this is elevation above its base. So the base of the tram, that's where the tram's starting. So it's not going to go down below that point at all. It's just going to go up from there in this case. Time, you could maybe argue of time being negative, like -5, 5 minutes ago, -5, but not a negative elevation from its base. Number 8, graph shows a proportional relationship between the temperature in degrees Celsius and the time in minutes during a science experiment. Write an equation to describe the relationship. So different points you guys could have picked on this graph. I chose the point 0, 0 and 2, -12. Didn't require a whole lot of thinking there. Perfect point. You technically could have picked, there was a point here you could have thought about was 1, -6. Again, since it's proportional, that's like our unit rate point. You could have gone with that idea, but just to make things interesting, 0, 0 and 2, -12, and change in y, change in x. So change in y is -12 because we're going down 12. Change in x would be 2, and -12 divided by 2 is -6. And so if -6 is our slope, then the equation would be y equals -6x. Part B, they want us to interpret the equation in words. So we just found we did temperature in degrees Celsius per minute. So that's degrees per minute, basically. And so that's telling us, since it's negative, that the temperature is decreasing 6 degrees per minute, 6 degrees Celsius per minute. And number 9, the bus is traveling 224 miles in 4 hours. They want us to write an equation that describes the relationship between the distance y and the time x. We're going to just have to assume this is proportional, otherwise we wouldn't be able to do this. So if it's proportional, we could just take 224 divided by 4, which is 56. So that's telling us it's going 56 miles per hour. And so our equation then would be y equals 56x. So this should give you a start that you have an idea of what you're doing when you work with these linear equations, y equals mx.